Okay, in chapter 602, we are ready to look at Mars. One of my favorite planets. Here's a look at Mars. This picture is taken from the Earth, so this would be something you could see through a good telescope. And you see the characteristic red color of Mars, which is due to the iron oxide dust that's being distributed through the planet. You can also see some surface features here. There's some dark surface feature underneath here. And you can see the polar ice cap on top. So Mars is truly the only planet where you can actually see surface features from Earth, and especially if the dust storms are not so large, you could possibly see what some of these features truly look like. Mars is named for the Roman god of war, possibly due to its red color, which is pretty evident even if you don't use a telescope. It's smaller and less reflective than Venus, but brighter than any star when at opposition. So as the Earth makes its closest approach to Mars, Mars will be the brightest object in the sky other than possibly Venus or the Moon, and brighter than any other star. Here's a direct comparison between Earth and Mars, and we can see Mars is much smaller than the Earth. In fact, its radius is only about 1/2 that of Earth's, and its mass is only about 10% that of Earth. So compared to Earth, it's quite small. If we were to look inside the interior of these planets, certainly if you look inside the interior of Earth, you would see a molten core and a mantle. And it's believed at one time Mars had a similar structure. It had a molten core and a mantle, and that it had volcanoes, because you can see the remnants of these volcanoes on its surface now. So at one time it was geologically active, and not believed to be so now, except in recent pictures in some of the ice areas. They're showing some dip-like depressions that look like there might have been some volcanic activity underneath the ice. So maybe, possibly, there might still be some geologic activity going on in Mars right now. Mars is 1.5 astronomical units away from the Sun. It completes one revolution of the Sun in 687 Earth days, approximately 2 years. And you can imagine, as the Earth is going around the Sun once and Mars is going around in 2 years, that as the Earth goes around in 1 year, Mars will go from one side to the other side. So if there was opposition in one particular year, then as the Earth made it around to the other next year, it would not see Mars, because Mars would be on the opposite side of the Sun. And hence the Earth will have to catch up to Mars in that next year, and finally you would get opposition again. So Mars would be hard to see except for every 2 years or so, when Earth becomes closer to the planet at opposition. Earth is 1 astronomical unit away, Mars 1.5. Earth has a 23.5 degree tilt, a prograde rotation, and an almost circular orbit. Mars has a 24 degree tilt, prograde rotation, and an eccentric elliptical orbit. So some similarity in terms of tilt there, and the fact that they both rotate in the same direction. Mars' surface gravity is only 38% that of Earth. So if you weigh 200 pounds on Earth, you would only weigh 76 pounds on Mars. Has a density similar to the Moon, almost 30% lower than that of Mercury, Venus, or Earth. So similar density to the Earth's mantle. Here's a look at Mars from space, and you can see a very prominent feature on its surface here, this rift valley called the Marineris Trench, Vallis Marineris, and you can see some volcanoes over here. The sidereal rotation period of Mars is 24 hours and 37 minutes, so it takes approximately 24.6 hours for Mars to rotate once on its axis, just slightly longer than our day. So a Mars day is very similar to a day on Earth in terms of light and dark. Here's a nice picture taken by the Hubble Space Telescope in 1997. You can see some of the features, more features of the polar ice cap and the dust storms and some other surface features of Mars. A Mars season is more severe than Earth's. The axis of rotation is slightly more severe than Earth's axis of rotation, 24 degrees as opposed to 23.5. Ours orbit is more eccentric in terms of elliptical orbit as opposed to the more circular orbit for Earth, so hence it gets closer and further away from the Sun. More contrast there than, say, for Earth. Energy for its wind comes from the carbon dioxide phase change between the frozen carbon dioxide and the gaseous carbon dioxide. Hence, you have more energy for wind, and the winds on Mars would be more severe, hurricane-like winds, 150 miles per hour, mostly over the surface, and hence much more severe. There are no oceans of water to mitigate the temperature changes, so on Earth you have a lot of water, and it kind of just stabilizes the temperature around the Earth between day and night, and cold and hot seasons. But on Mars you don't have that, so it's more severe, day and night, colder and hotter, and nothing to mitigate that, and also no thick atmosphere to help mitigate changes as well. So it's more severe in that sense. We could add even to this list the fact that Mars doesn't have a large moon, so the moon doesn't stabilize its axial tilt, so it tends to wobble more, and hence that would make its seasons more severe as well. Here's a look at the Earth relief map. If we use a Mercator relief map of Earth, we can see some of the geologic features of Earth. We can see the mid-Atlantic ridge here, the mountains there that lie underneath the ocean, and pretty much can see where the water in the Earth would lie. And most of Earth's water, oceans, lie in the southern hemisphere. If we do the same thing for Mars, we would see a relief map, Mercator relief map like this. This is showing it all the way around Mars on this one flat map. And we can see that the low regions of Mars is to the north. And it's believed at one time that was a super ocean, so that you had your ocean predominantly in the north, and to the south you had mountain highlands with all these craters looking very similar to the moon. We can see another feature of Mars, since this is showing the whole Mars all the way around. We can see a large depression on one side of Mars called the Hellas Basin, and a large bulge on the other side of Mars called the Tharsis Bulge. And features of this bulge are mountainous regions, some volcanoes, 3 in a row here, and the largest volcano in the solar system, Olympus Mons here, and a big crack across the face of Mars here called Vallis Marineris. If we expand this, here we have that large Hellas Basin, the largest depression on a planet in the solar system, and then we have this Tharsis Bulge on the opposite side of Mars, and it kind of looks like a cause and effect. It looks like something large came along and punched Mars on one side, and then as a result you have this Tharsis bulge on the other side, resulting in volcanic activity and this big crack across its surface. And it looks like that this is a possibility for what happened. Something large like an asteroid hit it on one side and caused this bulge on the opposite side. Northern Hemisphere plains are possibly a former ocean. The Southern Hemisphere. Theories about the surface of Mars in the past, in the late 1800s. There are some stories written about Mars, and they presumed that there might be intelligent life on Mars and that there were canals linking waterways on Mars. And in the early 1900s, in fact in the 1920s, the principal astronomer of the day, Percival Lowell, had the largest telescope of the day, and he focused it on Mars, and he was able to look closer at the surface of Mars. And so he made a drawing of the surface which looked like this. And this helped to continue to fuel the idea that there might be canals on Mars, because you can see these long straight lines, and they kind of look uniform. So it looks like there's some structure to these lines, that maybe some intelligent life left them there. So maybe due to this drawing, it helped continue this idea that there were canals and waterways on Mars. I was kind of wondering what exactly Lowell might have been looking at. And if you look at the Mars Global Surveyor picture of one side of Mars, you can see the Valles Marineris crack across one face of Mars, that large rift valley across its face. And this kind of looks like this dark area right here on Lowell's drawing. And you can see a extension here leading up to a highlands here, rather dark extension across this way. Looks like this part of Lowell's drawing as well. We have a dark area over here, this part, and then we have venturing over here into the Tharsis bulge, this part over here. So it really looks that like Lowell was looking from this picture from the Mars Global Surveyor, was looking at this face of Mars with the Valles Marineris and the features on that face. Here's a look at that face with the Valles Marineris. If we were to superimpose North America on this face of Mars, we can see that the whole continent almost takes up the whole face of Mars. Mars is relatively small compared to the Earth, so one large continent like North America would take up the whole face. And we can see that this crack across that face, this Valles Marineris, is pretty large. In comparison to North America, it would extend across the whole continent and maybe a little bit further. The Tharsis bulge itself is about the size of North America itself, and this Valles Marineris is 4,000 kilometers long, much larger than the Grand Canyon. Now, the extent from one coast of North America to the other coast of North America, a very large rift valley across its face. So we have this Valles Marineris, and we have this Tharsis region over here, and these volcanoes here. Here's another look at it, just turned slightly, and we can see clearly these nice three volcanoes in a row here. And we can see Olympus Mons up here, the largest volcano in the solar system. And to me, this look at Mars is very reminiscent of bowling. It kind of looks like bowling ball volcanoes. You got the thumb position here, and you got the finger positions here. So it kind of looks like a bowling ball. If you need a little bit of help, we can superimpose a bowling ball, and we can see the thumb and the finger position. It looks like Mars. In fact, this would be perfect because, as we know, Martians really only have three fingers. They got a thumb and two fingers, and hence you'd have the thumb position. Of course, you have three holes there, but that gives you some options for the bowling. But it kind of looks like Martians would enjoy bowling. Here is that largest volcano in the solar system, Olympus Mons. It's a huge shield volcano, which means that as the lava flowed, it just kind of flowed over the top and just kind of gently went down across the sides, building up its way that way, as opposed to a tephro type volcano, which cinder cone, which shoots material out and is a violent volcano. This is more of a gradual sloping volcano, and eventually creating itself in the shape of a shield. So it sat over a hot spot at one time in Mars' mantle and gave the shield effect. Here's another look at Olympus Mons. We can see that shield effect to it. And it has a chance to become this large volcano because Mars' gravity is so low. So it's allowed to grow up far beyond the surface of Mars. Earth has somewhat comparable volcanoes in Mauna Loa and Mauna Kea in Hawaii, because those volcanoes reach all the way down to the floor of the ocean. That would be the closest thing we'd have to something like Olympus Mons. Here's something also similar between Earth and Mars. If we look on the left, this is a Mars runoff channel. At least it appears that way. On the right is a picture of Earth's Red River in Louisiana. And they look very similar, just somewhat by coincidence, but it's somewhat circumstantial evidence that this was water flow at one time, large water flow at one time, along Mars' surface. Here's evidence of more outflow from a large amount of water being flowing and depositing this material, sort of in a delta type situation, and leaving it there and giving us evidence of large amounts of water at one time moving on Mars. Here's a more recent picture showing enhancement of different types of clays that are on the surface of Mars, and we can see the outflow into this, depositing sort of like a delta into all these different clays, and again, very good circumstantial evidence of large amounts of water once flowing on the surface of Mars. Here's a frozen outflow. It kind of looks like there was frozen permafrost underneath the surface of Mars, and you got hit by a meteorite, or a large meteorite, and that was so much energy in that it melted all this permafrost into flowing water, start to flow, and then that refroze. So you have your outflow is refrozen in, and again, evidence that there was a lot of water on Mars, and may still be a lot of water on Mars in what might be frozen permafrost underneath the surface. Well, NASA's taken several journeys to Mars, and most recently, in 2004, it landed 2 rovers onto Mars, the Spirit and Opportunity. Opportunity landed in Meridiana Planum, kind of on the border of this, what is thought to be this northern ocean and the highlands. And Spirit landed exactly on the opposite side of Mars, in Gusev crater, again trying to be on this border of the ocean and the highlands in order to look for the possibility of water and maybe the possibility of ancient life on Mars. And here's some circumstantial evidence that they found. Here you see these pebbles that look like they're kind of rounded due to some kind of water type erosion. A smaller fragment material, finer material, different colors, different composition, very similar to sedimentary material that you would find in the outflow of water on Earth. And if you look microscopically, you can find these beads, and this is what Opportunity found on the surface of Mars. Again, circumstantial evidence of water, but very good hints of lots of water on Mars. Well, there actually is proof of water on Mars. I mean, the Mars Global Surveyor has taken pictures of the polar ice caps, and in polar ice caps you have water ice. You also have other ices. You have carbon dioxide, dry ice, in the polar ice caps, and other ices as well. Here's a good picture of the south polar ice cap of Mars. And here's a picture, close-up picture of the south polar ice cap. Again, if you do elemental analysis of this ice, you will find in there somewhere water. Odyssey, Mars Odyssey, has the first claim to proving that there's water on Mars by elemental analysis by looking at the ice cap. Here's a north polar ice cap of Mars taken by Mars Global Surveyor. Nice picture of Mars. And looking at this north polar ice cap, we can see position where the Phoenix lander in 2008 landed on Mars to definitely look for samples of water, possibly analyze the soil and these samples for maybe the ancient possibility of life. And when the Phoenix lander actually dipped into the soil, it actually had a way to analyze the soil, and it made these dips, and you can see maybe evidence of leftover ice here as well. And it analyzed these dips, it found water. So water has been tasted on the surface of Mars by the Phoenix lander. So there truly has been water, lots of water on Mars in the past. There's water there now. So the next question is there life on Mars? Well, if you're a NASA scientist, you would hope that you'd be able to find some definite sign that there is life on Mars. And certainly a definite sign, like maybe a sign that said life is here, would be good. I mean, that'd be really nice if you saw that sign, life is here, then you would know there was life on Mars. But even something like Eat at Joe's, classic American diner, that would definitely prove that there was intelligent life on Mars. That'd be nice. Well, we do have a sample of Mars here on Earth. At least it's believed to be so. Back in 1984, a meteorite was found in Antarctica, and it was brought home and it was cataloged and stored away. And later on, it was brought out and it was found that it's believed that this meteorite actually came from Mars, and that there's some ancient collision on Mars, threw out this material into space, and somehow that material found its way to Earth and landed on Earth. And hence it was cut into, and when this meteorite was cut into, it found structures that looked like they might have been produced by bacteria. It was proven, or at least believed to be proven, that this was from Mars by looking at the trapped gases within the sample, and the ratio of those gases were exactly the ratio that would be believed to be in the atmosphere of Mars. It found chemical compounds that normally would be associated with biology, life processes, and they found these rod-like structures that kind of look like they might be fossils of bacteria. So, the scientists who discovered this made an announcement about mid-1990s, about 1995 or so, and said that this is definite proof that there was life on Mars. However, there were other scientists who came forth and said, well, these chemical compounds could be produced by other ways, And these rod-like structures are kind of too small. They may not have been produced by bacteria. So it's not really definite proof that there's life on Mars, or was life on Mars. And to be honest, this sample was discovered on Earth. As we know, Earth has life, so it's possibly that this, at least this is my opinion, this sample could have been contaminated by life from Earth. So it's not necessarily definite proof that there was life on Mars. But here's a picture taken by the most recent 2004 Opportunity mission. As you look in this picture, you can see these strands of fiber-like material. So maybe that is evidence of some type of textile material from some ancient intelligent life that resides on Mars. Or maybe it's just a piece of the balloons that were used to help soften the blow when Opportunity landed on Mars. In fact, that's what it is. So those are strands of intelligent life material, but it came from Earth. So anyway, Opportunity looked further and they found this curlicue type structure, which kind of looks like Rotini pasta. So maybe there's, if not only intelligent life on Mars, maybe Italian life on Mars that could cook this nice Italian pasta-like stuff. But then they found out that the drilling mechanism from Opportunity could produce this kind of curlicue result, and hence that's really just a result of us drilling into the rock, not life on Mars. Well, here's an interesting structure found by the Spirit rover. And if you look at this structure, it looks symmetric all the way around, which symmetry is always a nice thing to find if you're looking for life. And it looks like it's radially projecting outward, kind of like a lichen on Earth. In other words, this structure was likened to lichen on Earth. So maybe it's biological. It kind of looks like a fungus on Earth. Until it was found that the polishing device on Spirit could produce the same effect, and probably did produce the same effect. So it's not really necessarily biological. Well, there is a face on Mars, though, and we're going to look at this face. It's not necessarily in this picture. Oh, there's, that's not the face we're looking for. Before we introduce the face on Mars, we have to do a little explanation. You see, when we look at things, it's human nature to try to put in familiar objects with what you look at. The human brain tries to associate familiarity with what you're looking at. So sometimes the brain can be fooled. Magicians use this concept all the time. They can fool the brain because you're expecting to see something. And also, the eyes are biological, so there's a time lapse there. And so magicians can fool the human eye. And in fact, as you're trying to look for things, if you read this paragraph, according to research at Cambridge University, it doesn't matter in what order the letters of a word are. The only important thing is that the first and last letter be in the right place. The rest can be a total mess, and you can still read it without problem. This is because the human mind does not read every letter by itself, but the word as a whole. In other words, the human brain fits in the extra stuff that you need to know in order to be able to visualize or read something. The brain tries to fill in what it expects to be there. Now we can look at the following photos. As you look into that little rectangle, that's where we're headed. Here's a higher resolution of that area, and you might be able to now recognize the face somewhere in this picture, but we're going to go to even higher resolution. So NASA's looking for a good place to land. And as it releases these photos, they kind of knew that it might cause a little stir, because here's a nice looking face on the surface of Mars. And since then, there are a lot of internet sites that will profess that this indeed is a face. Not only that, that there's a city block over here with pyramid-like structures, and hence all these structures together, the face being some kind of sphinx type structure and monument, and you have these pyramids, definite evidence of an ancient civilization on Mars, at least thought to be by these internet sites. As we look closer at the face, it does look like a human face here by this resolution, but I wonder why we just focus on the face. Why don't we focus on this structure over here, which to me kind of looks like a hippopotamus. Here's a little help. It looks like a hippopotamus. And why don't we focus on this structure over here, which to me looks like an upside down Gumby. See? In other words, you could probably fit different things to different structures that kind of look like things, but they're not necessarily those things. I still think that looks like a hippopotamus and that looks like Gumby. Here's the face. What might have caused this face? Well, maybe it is some ancient civilization. You know, Mars is cold and it's got this water and this permafrost on the surface. So if you lived on Mars, one of the sports that you probably would be interested in playing would be hockey. Makes sense. And so maybe this structure is some kind of monument to famed goaltender, Hall of Fame goaltender, Grant Fuhrer. Kind of looks like him with a little bit of erosion. Unless you look at higher resolution. Here is the resolution of the Viking orbiter in 1976, where it looks like a face. But since then, the Mars Global Surveyor has been going around Mars for many years and took high resolution of the whole surface of Mars. And back in 2001, scientists finally said, well, let's go over the face and let's get a higher resolution of that picture. And the Mars Global Surveyor did, and came up with this picture. And you can see clearly in this picture, it's no longer a face. You've got depression here, better features, the face is not there. So definitely there's no sign of intelligent life in this face. Oh! No sign of intelligent life in that face. Here's a morphing between the Viking orbital picture and the Mars Global Surveyor picture. You can see as we go through these features from the low resolution Viking in the shadows to the higher resolution Mars Global Surveyor, definitely it's just imagination at play and shadows working with the human brain. No face. Well, there might be another face on Mars, though, the happy face in one of these craters. As we turn this around, we can see what looks like a happy face and a couple of eyes. Most likely this is a double crater, so you can see the rebound effect of the impact of this meteorite. Here's a head-on look where you see the face and the eyes. Definitely no American life, no intelligent life on this surface. Oh, missed that one. Definitely too much time on my hands, right? So here's a summary of the missions to Mars. Mars has been visited by 6 working NASA European Space Agency landers. Viking 1 and Viking 2 in 1976 landed on Mars, took nice pictures. We saw the iron oxide which is causing the redness of the planet. Mars Pathfinder landed in 1997, took many pictures as well, and had that Sojourner robot moving around. Spirit and Opportunity landed in 2004. They were supposed to be only 3-month missions with their solar batteries, but they're still going strong. So they've been roaming around Mars for many years now. European Space Agency's Beagle 2 crashed. That's not the way they put it when it happened. They just said it failed to respond upon landing. Crashed. Phoenix landed in 2008, took that nice scoop of Mars soil, analyzed it, found water. So our recent probes, the Mars Global Surveyor, which did not land on Mars but has been mapping the surface of Mars since the late 1990s. It's been very useful. Pathfinder analyzed the soil, rocks, and the atmosphere of Mars. The Mars Climate Orbiter accidentally burned up. The Mars Polar Lander, designed to land probably similar to Phoenix, in 1999 accidentally crashed. So after that they developed that balloon landing, which was a good idea to bounce around on the balloons. 2004 Spirit and Opportunity found evidence of water. And finally, 2008 Phoenix Lander tasted water. Here's a nice picture of a path of Spirit as it roamed along Mars over several months, made it to this highland area. And I was just looking at this picture and saying, if you're looking for faces on Mars, there appears to be a face over here. It looks like a profile. You can see the chin, the mouth, and the eyes, and the nose. Let's blow that up. See? This looks like a profile. You got the chin, the mouth, nose, eyes. With not too much imagination, this looks like a monument to one of our famous presidents, Franklin Delano Roosevelt, whose face is on the dime. Looks very similar to his profile. Huh? I was also looking at this picture the other day, and it looks like to me that there might be another face here. You can see a mouth here, a smiling mouth, a nose here, cheekbones, an eye here, and an eye here, looking right at you. You see that? Here's a little help. Kind of looks to me like Jack Frost. Let's go back. See? Mouth, nose, eye, cheekbones. Jack Frost? Alright, yes, too much time on my hands. Definitely. Here's what Spirit saw in that highland area, and it saw this, what they called home plate. It saw these rather flat-like rocks, and no real good explanation for these types of rocks. Kind of look like shale that you might, or slate that you might see on Earth, which is a sedimentary metamorphic type rock. Here's some other Martian facts. Mars has a lot of iron oxide or rust. Mars has no magnetic field, so evidence that there's a non-metallic or non-liquid core now, because Mars does spin, so if it did have a liquid core, it should have a dynamo effect producing a magnetic field, and it doesn't have that. So maybe it doesn't have that geological aspect to it anymore. This is a famous picture. This is the first picture taken of the surface of Mars by the Viking lander, and you can see a part of the lander right here. This was taken on July 20th, 1976. What is the significance of July 20th? That was the same day that human beings first stepped on the moon, July 20th, 1969. So this picture was taken exactly 7 years after the first human stepped on the moon. And that was probably by design. If we look at the atmosphere of Mars, we can see it's dusty iron oxide, making it look red. It's extremely thin, about 1/150th of the Earth's atmosphere. Composed mainly of carbon dioxide, 96%. However, you don't have this runaway greenhouse effect like you have on Venus because it's so thin. It's 1/150th. It's not like 90 atmospheres. Maybe the atmosphere was much denser in the past, allowing to have liquid water and warmer temperatures, but most of the atmosphere has been lost because Mars has such a weak gravity. The loss of carbon dioxide has resulted in lower temperatures and the freezing of liquid water to underground permafrost. So any liquid water, that large ocean that might have been there at one time, gone, either evaporated or frozen underneath the soil. Here's a beautiful picture of the surface of Mars. Iron degrees Fahrenheit to 270 degrees Kelvin, about 30 degrees Fahrenheit, so almost up to the freezing temperature of water. Hence, you could probably wear a nice overcoat and withstand that warmest temperature. And actually, water might even sometimes melt on the surface. But the cold temperature, the nighttime temperature, would be unbearable, minus 140 degrees Fahrenheit. Some nice pictures of Mars. Here's a metal container that maybe a Martian left laying around. Here's a robot. It's not by Martians though. It's the Sojourner robot left there by the Pathfinder mission, and it moved around taking samples. Here it is trying to move this rock out of the way so that you can get a clearer picture of the surface of Mars. No, I just kind of ran into that rock. Here's Mars. You can see the dust storm going up here. Mars is marked by hurricane-level winds fueled by the phase change of carbon dioxide, so it's a much more energetic change than, say, the way that winds are fueled on Earth, which is the phase change of water. So on Mars, you have more energy. The winds get up to 150 miles per hour, hurricane winds all the time. It would not be a fun place to have all this sand and dust flying at hurricane speeds. Some nice pictures of the surface. Here's one of the rovers. I don't remember if it's Spirit or Opportunity. You can see how fine and thick the dust is on the surface of Mars. In fact, Spirit got stuck. It was moving along, and it got into dust about 6 inches deep, got stuck, and it took 6 weeks to free it. In fact, they weren't sure they were going to be able to free it at all. They thought they had lost the rover. But they had to send signals from Earth, which takes minutes, and they would have gradually moved them backwards out of where it got stuck. And so you would take several minutes to do that, and then minutes back, and you have to do it slowly so you don't spin the wheels. And over the course of 6 weeks, they were finally able to free the rover. Here's an army of Pac-Men. These are really Pac-Man dunes caused by the wind on Mars. Ice dunes. So you have a wind effect from the lower right and the sun at the upper right, making these nice features here. Here are some other dunes. They kind of look like birds, but just nice symmetric type features on the surface of Mars. Kind of reminds you of an M.C. Escher type painting. Here's M.C. Escher where you got the birds and they kind of meld into the fish, and it's kind of an optical thing. Looks pretty neat. Here's a video of a Mars sunset. You can see how small the sun appears on Mars because Mars is so much further away from the sun than we are. Here's the sun setting on Mars. Here's the Mars sky. All this iron oxide makes the Mars sky appear red, so it's not blue like ours. It is reddish due to all this dust in the sky. Mars has moons. Mars has two moons, Phobos and Deimos. Here's a picture of Phobos with Mars in the background. Mars, of course, is the Roman god of war, so the companions of Mars is Phobos, fear, and Deimos, panic. So the god of war has fear and panic as his subjects. Discovered in 1877 by Asaph Hall. They're extremely tiny and irregularly shaped with low gravity. They do not appear to have been formed with Mars. In fact, they look like, and most likely are, captured asteroids. Densities are much less than Mars, about 2 grams per cubic centimeter, so they are like dirty ice balls, ice rock balls, captured asteroids from the nearby asteroid belt. Because Mars has a problem with that. Mars is right next to the asteroid belt. You know, Earth has a problem with possibly Earth-crossing asteroids, but Mars has a lot of Mars-crossing asteroids. And in fact, maybe one of them hit Mars at one time, causing that Hellas Basin and the Tharsis Bulge on the other side. And then it captured these other 2 asteroids, Phobos and Deimos. Here's a close-up look at Phobos and Deimos. They would be good places to land before you approach Mars because they'd be like little satellites out there, so you don't have to build your own little space station. Just land on one of these moons, these little moons, and set up your shop so you don't have to deal with the 150-mile-per-hour hurricane winds on the surface of Mars. And just set up shop, set up your study, and then take trips to the surface. That'd be a good thing to do. Phobos is about 28 kilometers or 17 miles long. Deimos, which looks much different than Phobos, is about 16 kilometers or 10 miles long. Both of them are about the size of a large Earth city, not bigger than that. Here's a close-up of Phobos, and it was hit by something large, almost cracked it by this object here. Kind of looks like a deflated old football from the old football days. I feel like putting on a leather cap and taking this Phobos out and giving it a good kick. It was kicked one time too often on this end. Well, that concludes our study of Mars. It's time for us to say goodbye. So we shall wave goodbye as Mars waves goodbye to us Earthlings.